Good morning, or actually that's when I'm making this, it's in the morning. You may be watching this in the evening. Who knows what time you'll be watching this. But good whatever time it is for you. In this video, I look at the data structures of the room class of the Better Zuul project in your textbook. Now, the room class works with other classes, the game class and the parser class and the command names classes. But in this video, we're pretty much going to look just at the room class. And talk a bit about the game class and how it interacts with the objects of the room class. But that we won't talk about the other classes. So each game object has two fields. It has a description field, which is a string, and it has a hash map field, which consists of key value pairs, K and V, K obviously for key, V for value. That's a convention which you should be familiar with. The key in the exits, in the hash map, which is called exits, is a string, and it is the name of the room that the exit leads to. And the room is the value, and that's a reference or the address of the actual room object that that key is associated with or maps to. That's where the word map comes from. So the key maps to this key maps to this value. So, for instance, see, rotate this so it's clear. This key, which for argument's sake, let's say this is hallway, the string hallway, leads to this room, which is the hallway. And this key maps to this room, which might be, I don't know, the kitchen. And this key might be attic, and it maps to this room, which is the attic room. And of course, each of these rooms have their own descriptions and their own hash maps of exits. Pretty straightforward. And the advantage to this approach is that the user, the game class can ask the room, can pass in a string to the room, which the user has typed in, and say the user types in go, what did we say this was? We said this was hallway, I think. So if the user types in go hallway, hallway is passed into a method that's in the room class, and that method basically asks the hash map, hey, do you have a key hallway? And it does in this example. So it says, okay, yeah, I have a key hallway, and that maps to this room. So then the method returns the address of this room. And we can then move to that room, and that becomes the current room in the game. So really easy to search through this based upon the key. Also really easy to add as many key value pairs as you want. Now, you could have as few as one. You could have no key value pairs in exits. You could have one. You could have 1,000. Right? I've only indicated the 3 that are, I've drawn out here 3, but you could have as many as you want or as few as you want. And that gives you a lot of flexibility. So rooms could have lots of exits or just a few exits. And it's then easy to search. Again, it's really easy to search through those exits using using the key value, and find the exit and return the room that's associated with it if it's there. Now, one of the things that I'm going to ask you to do in the game is, or I have asked you to do in the game, is to add the functionality so that in addition to having exits, a room can have a number of items in it. May have a number of items, doesn't have to, but can have one or more items in it. So you should think, well, if a hash map works really well for having one or more exits from a room, might be a good idea to use for handling one or more items that a room can have, that can be in a room. So the first thing you need to do for this is to create an item class. Here's an object of the item class, and as you can see, it's very, very simple. It's a single field, which is a description. It's a string field, and it would have a constructor method that would set the description and an accessor method which would return the description. You could add additional functionality, but that's all you need for this project. So what you would want to do to be able to allow rooms to hold items is to, in your room class, to add another hash map. The key would be a string, and the value would be item, because it's item objects that are referenced in the hash map, and you'd probably want to call it something like items. So I'm going to just show one that I made previously here. And so here's a hash map of items. And if we wanted this item to be in this room, when the items, when you make the new items object in the constructor of the room class, it would be empty. I just drew a bunch so you'd get the sense of that it can hold a bunch. And if we wanted to add an item to the hash map here, we would just add a key value pair to the hash map that had the name of the item, something we would supply. So say this was a, what would be a good item to put in a room? Let's say that this is a cup. Said that because I just looked down and had my teacup in front of me. So we would have, from the value, we would have, the value for this would be the address of this item object, which is, the description would be something like a nice brown teacup. And we could add as many items as we want to the hash map, or none. And we could ask each room object to give us the list of items that it contains in the same way virtually that we ask, the current code that you start with allows us to ask each room object the exits that room has. And we could get items that are in the room in a very similar fashion to how we get exits from a room. So if you look at the existing code for the room class, you'll see methods for displaying the, or actually returning as a string, the exits from the room. And you'll see a method that allows you to get an exit. You supply a key, and if a matching key is found in the hash map, then the associated room is returned. It's returned back to the game class where this method would be called from. And the game class then makes the room that's returned the current room in the game. So that's how you actually, that's how the player moves between the different rooms in the game. Very similar things could be done with the items hash map. The user could supply the name of an item, use a command like get item, the string that the user typed for the item name, would be passed into a method of the room class. The item's hash map would be searched to see if there was a matching key. If that matching key was found, then the item, the matching item, say this item, could be returned to the player, to the game class, and something appropriate could be done with it. It could be added to the player's inventory, or something else. So that's pretty much how this all works. Get rid of that. But you get the idea. There's a reference from that value to this item. You could add as many rooms as you want. The hash map provides that flexibility. You could add as many items to each room as you want. Again, the hash map for the items provides that flexibility. The code that you need to work with the items hash map is very similar to the code that you need to work, the existing code that works with the exits hash map. So you can actually copy those methods and just make a few modifications to them. So I hope that gives you a little bit better understanding of how the room class data structures work, and the wonderful flexibility and usefulness of hash maps. Thanks.